Today we are going to learn about the discriminant to find out information about the amount and types of roots of a quadratic function. This is the formula for the discriminant. B squared minus 4 times A times C. Now what do the B and A and C represent? Well, they represent the numbers that we see in a quadratic function. So the A is the coefficient of the x squared term, or what we call the lead coefficient. The B represents the coefficient in front of the x term in a quadratic function. And the C represents the constant. So B, A, and C are not the variable terms, the variables in the terms, but they are the coefficients or the constant. Now, when calculating the discriminant of a specific function, we can find out more information about the roots or the solutions, also called the solutions of a quadratic function. So first, let's talk about just how to calculate the discriminant. We're going to give an example here. And I can use x, or I can use any letter really to represent the function. So notice that the equation y equals is set already in standard form. This is the standard form of a quadratic function. And then we set it equal to, so we set y equal to 0, because the roots of any quadratic equation always has a 0 in the place of y. Then we are going to identify the A, the B, and the C. The A is the lead coefficient, it's a positive 6. The B is the coefficient of x, and notice I also circled or squared the sign. The sign that goes in front of the number belongs to that number. It's a -2. And same way, in this case, it's a -3, so that's a -3. So now I can calculate the discriminant. So think of it as step 1, find A, B, and C, and calculate the discriminant. And I start by creating placeholders for B, A, and C. So we have parentheses square for B squared, -4, parentheses empty for my A, parentheses for my C. Now, some students get really excited and don't pay close attention to the formula, and they go ahead and just go in order. They put the A, they put the B, they put the C. But this is not correct. It should be B squared minus 4AC. B squared minus 4AC. And instead of plugging in the value of B, they plugged in the value of A. Instead of plugging the value of A, they plugged in the value of B. So what people end up doing is doing A squared minus 4BC, and that's not what the formula for the discriminant is. It's B squared minus 4AC. So it's really important that we pay close attention. And in state exams, the regions, the quadratic formula is given to us, and we'll see in the next video that the discriminant is a part of that quadratic formula. So you don't even have to memorize it. So the b squared, so that's -2, and you have to use the parentheses because the calculator will make a mistake for you. Then for a is 6 times c is -3. And then exactly as you see it here, you plug it into the calculator, and you get a discriminant of 76. So that's part 1 when you're being asked to find a discriminant. Let's do find a discriminant of another function. Let's do y equals -2x squared minus x minus 1, and we're going to set it equal to 0 because again the roots are always have y equal to 0. So step 1, we want to find a, b, and c. A is the lead coefficient, the coefficient in front of x squared. I'm always going to make sure that the sign in front is highlighted. Now some people see that and stop in their tracks, but no need to get to freak out or anything. If you don't see a coefficient, it's 1. But in this case, it's a -1 because of the sign. So your b is -1. And then c is -1. So then we take our formula and we're going to put parentheses in place of b, a, and c. So I know that maybe you can rewrite it here so you don't forget what goes in the parentheses. So b squared, so parentheses b squared, minus 4a, parentheses for a, c, parentheses for c. And inside I'm going to plug in the -1 because b goes first, then a goes there, and then your c goes here. And then when you plug this whole thing in your calculator, just exactly as you see it, you're gonna get a -7. Now here's one thing you need to keep in mind when using calculators, especially if you use a graphing calculator. For some reason, there are 2 different buttons for negative and minus when they really should be the same thing, because intuitively they are the same. So when you are plugging in a negative number, you're going to use the button that looks like this in the graphing calculator. Also scientific calculators typically is at the very bottom. And then when you're subtracting 4, you're going to use the minus button. It's typically either above or below the plus sign. If you use the wrong one, if you use the subtraction here, this one, and here you use the negative instead of -4, it will not give you the correct answer. Okay, so notice that at any point did not have any variables inside of here, because a, b, and c are not variables. They're just the numbers that you see in the quadratic function. The numbers in the coefficient or the constant, which is your c. Let's do another one, and then we will do one where it's not set equal to 0, okay? Because sometimes you'll see it that way. So here's an example where the function is not set equal to 0. We have -x squared minus 9 is equal to 6x. Okay. And we want it to set equal to 0. So in order to do that, remember when we're thinking about equations, it's a balance scale. It's a balance scale. Whatever we do to one side of the balance scale, we do it to the other side. If we add 2 pounds, we have to add 2 pounds so it remains balanced. If we take away 2 pounds, we take away 2 pounds, it remains balanced. That's what the equal signs means. Okay? So for example, I have 2. 2 is equal to 2. But if I'm going to add 3 to one side, I have to do it on the other side. Otherwise, I get the false statement that 2 is equal to 5. So you have to make sure whatever you do to one side, you do it to the other side. So we have to take away the 6x by doing the opposite. 6x was added here, so now we're going to subtract. But whatever I subtract from one side, I do it to the other side. 6 take away 6 gives me 0. And now we're going to get our trinomial. None of these are like terms because none of them have the same variable and same exponent. This is a number, and a number can't combine with x terms. This is an x squared term, this is an x to the first term. So while they do have the same variable, they don't have the same exponent. So what do? You just bring it down in standard form. You start with the variable with the x to the second power, then you bring the term that has the x to the first power, and then you bring down the constant. So now it's equal to 0 because our root says that our y is equal to 0, and it's in standard form. Now to make space, I'm going to rewrite this up here. Feel free to, in your paper, if you're following along, you don't have to do what I'm doing. I'm going to erase just to make space. Okay, so I'm just going to put that here. Negative x squared minus 6x minus 9 is equal to 0. I'm going to put my invisible negative 1 there. So now I can step 1. Well, technically step 2 because step 1 was set at equal to 0, so that was done. So now in this case, finding a, b, and c's are step 2 because this was not set equal to 0. So we have negative 1 is my a, negative 6 is my b, negative 9 is my c. You want to make sure the sign follows. So now I can plug in b squared minus 4ac. And I'm going to now this side, I'm going to rewrite it with my placeholders for b, my placeholder for a, my placeholder for c. And I'm going to make sure I'm bringing down my b first, not my a, because the formula says b squared. Then I bring down my a, then I bring down my 9, and this is what I plug into the calculator exactly as I see it. Make sure I'm using my minus sign for here for minus 4, but then my negative sign in my calculator for the numbers, and I get 0. So again, remember a, b, and c don't have variables. It's just the numbers that you see in a quadratic equation written in standard form such that we set it equal to 0. Now, part 2 of a problem like this, once you know the value of the discriminant, okay, for example, the one we just did, the example where we had negative x squared minus 6x minus 9, we found that the discriminant was equal to 0. Discriminant was equal to 0. So this discriminant tells us something really important. If you solve for the discriminants in your first step, and you solve it such that you get the number 0, then that tells us something really, really important about the roots. It tells us that if your discriminant is equal to 0, then you have one real solution. Let's erase this part here. One real solution one x-intercept. So if your discriminant is equal to 0, then that means that your quadratic function, in this case we know it's facing down because of the negative, is touching the x-axis one time. That one is the root, one real solution, because it's touching the x-axis, therefore has one x-intercept, because the discriminant is 0. If your discriminant is less than 0 or negative, then that's telling us, like the last one we did, we got a negative number. Yeah, we got a -7. That is telling us that we don't have any real solutions. We have two imaginary solutions. I can't fit the word imaginary here. That's telling us that we have two imaginary solutions and no x-intercept. So you can imagine a parabola, a x function, a quadratic function, floating in the air like this or like this, where it will never ever touch the x-axis. No x-intercept. And when we solve using the quadratic equation, we'll see that we have a negative discriminant. And when we solve, we're going to get a number that does not represent a real solution. It represents imaginary solutions. Now your discriminant, if it's positive, there are two things, two different scenarios. So let's look at that. If your discriminant is positive, greater than 0, then there are two options. Option A is discriminant is a perfect square. Like 4, 9, 25, 16. If it's a perfect square, example, you get 16 when you solve for b squared minus 4ac. And you have two rational solutions. And rational and irrational are real, not imaginary. And two x-intercepts. Now, the other scenario for a positive discriminant greater than 0 is you get a number that is not a perfect square, like 5. Or in this case, 15 is not a perfect square. Can't find a number that multiplies itself to get 15. Then you get two irrational. And rational, irrational are real, as I mentioned. Two irrational solutions, two x-intercepts. And remember, you do have to state the intercepts and the solutions, because as we saw when the discriminant was negative, you can get solutions that aren't real, but then no intercepts. Okay. So a way to think about what they would look like here's my x-axis. So we have 2 intercepts. But you are going to get 2 numbers that are rational. Like whole numbers are rational. 2 and 6. Rational numbers are any numbers that can be represented as a fraction. Like 1/3, 2/5, or whole numbers, because whole numbers can be represented as fractions of 2 integers. Notice there's 2 x-intercepts. And in here, similarly, there will be 2 x-intercepts, but your solutions cannot be represented by rational numbers. They can only be represented by irrational numbers, like radical 2 and radical 5, for example. These numbers would be numbers that go on forever. They can't be written as whole numbers, so they're going to have some sort of radical expression to represent their irrational solutions. So the discriminant is really important because it tells us a lot about the type of solutions that a quadratic function will have. So I'm just going to go ahead and if discriminant 0, example, 0, this is 0, you have 1 real solution, 1 x-intercept. And then we said the discriminant is a negative number, in other words less than 0. Basically a negative number. Then we said we have 2 imaginary solutions. We'll talk about imaginary solutions in another video. What does it mean for a number to be imaginary? And no or 0 x-intercepts. So part A, solve, find discriminant, and then given the number that you got, look at your chart. Is it a positive number? If so, is it a perfect square or not a perfect square? Is it 0 or is it a negative number? And based on which of these you get, then you can find out the types of roots that you will get. Alright, that's all folks for today. Hope this makes a little more sense. Once we solve using the quadratic equation, and we'll see the discriminant up there will make more sense, hopefully. Take care.